Welcome back, future electrician and lighting pros. In today's lesson, we're going to break down a really important question. How do LEDs actually work? Now, you've probably used LED lights before, on your phone, your car, or around the house. But do you know what's going on inside those little things? It's not quite like the old school light bulb, not even close. Let's walk through it step by step, using simple terms so you can build a solid foundation in modern lighting. First, let's talk about why this topic matters. Old lighting systems, like incandescent bulbs, fluorescent tubes, and HID lamps, use heat or gas to make light. But LEDs are completely different. They use electronics like a chip technology. As the industry moves more and more towards LED lighting, it's important for anyone in the electrical field to understand how LEDs produce light, because this affects how we install, troubleshoot, and even choose lighting systems. So let's break it all down. LED stands for light emitting diode. Let's start with the second part of that, a diode. A diode is a tiny electronic component that allows electrical current to flow in just one direction. Think of it like a one-way street for electricity. But unlike a regular diode, an LED has a special feature. When electricity flows through it, it gives off light. How? Well, here's what's happening inside the chip. Inside every LED, there's a tiny semiconductor chip made from two special materials, each one with different electrical properties. These materials are placed together inside the chip, and when electricity flows through them, electrons in one of the materials get excited. That means they move to a higher energy state because of electricity passing through. But electrons don't like staying excited for long. They quickly fall back down to the lower energy state. When that happens, they release extra energy they had, and that energy comes out as light. That's it. It's a simple but amazing process. It all happens at the atomic level, and it happens instantly without no heat, no filaments, and no gas involved. Here's another cool part. The color of the light that comes from the LED depends on the material used to make the chip. Different combinations of elements like gallium, nitrogen, and indium will change the color of the light. Use one material mix and you get red. Use another and you get green, blue, or white. In fact, white LEDs are usually made by combining blue LEDs with phosphor coating that shifts the light to appear white to the human eye. This is one of the reasons LEDs are so flexible. They can be designed for any color temperature, from warm yellowish light to bright daylight white. Okay, so what does all this mean for you as a future electrician or technician? Here are a few takeaways. LEDs don't have filaments to burn out like incandescent bulbs or gases to leak like fluorescent tubes. That's one reason they last so long, often 25 to 50,000 hours or more. Because LEDs are electronic components, they need proper drivers, kind of like ballast for HIDs or fluorescent, to control the current and voltage. LEDs run cooler than traditional lights, but they still need heat sinks to manage the small amount of heat they generate. overheating can reduce their lifespan. LEDs are directional, meaning they shine light in a specific direction instead of all around them like traditional bulbs. This makes them more efficient in task lighting and other focused applications. Because they are efficient, durable, and flexible, LEDs are quickly becoming the go-to choice for nearly every lighting job, indoor and outdoor, residential and commercial. Let's wrap it all up with a quick recap in plain language. An LED is a type of diode, a device that lets electricity flow in one way. Inside the LED chip, electrons get excited, then drop back down, releasing light energy. The color of the light depends on what materials are used in the chip. LEDs are efficient, durable, and long-lasting, and they are taking over the lighting industry. As someone entering the electrical field, understanding how LEDs works gives you a strong advantage. You'll be ready to explain lighting choices to customers, install LED systems confidently, and diagnose problems faster on the job. So next time you see a little glowing light, remember, you're not just looking at a bulb, you're looking at the power of semiconductor physics in action. Thanks for tuning in, and keep lighting the way forward.